Good day everyone, welcome to my class. Today we're going to talk about science, and by the way, it's me, Ma'am Princess, and I'm going to guide you regarding our topic for this day. In today's lesson, we are going to talk about potential energy, introduction, and calculation. I know that you are very familiar with this word since you were able to have it in grade 7. But before we move on to the calculation of the potential energy, let us first define potential energy. It is the energy stored in an object, and potential simply means as the energy that has something to do or useful later on. Actually, in our real life experiences, we have this potential energy, such as the potential energy present in the stretched rubber band or in a drawn bow and arrow, as well as the potential energy present on the water at the top of a waterfall, which is also known as gravitational potential energy. In calculating the potential energy, do not forget this general formula of potential energy, which is equal to PE is equal to M times G times H, wherein M stands for mass, that is always in a unit of kilogram. G stands for gravity or acceleration due to gravity, with a standard value of 9.8 Newton per kilogram. It will never change. This is the standard value for acceleration due to gravity, 9.8 Newton per kilogram, as well as height, that is always in meter. Remember that the standard unit for energy is joules with the symbol of J, and the expanded form of joules is Newton meter. So it's just the same. Joules or J is also the same with Newton meter. Let us have our problem number 1. What is the gravitational potential energy of a boy who has a mass of 50 kg and is standing on the edge of the diving board at 5 meters above the water? So in order for you to better understand this, again, you need to use GRESA. And we all know that GRESA stands for G as a given. And 50 kg from the unit itself is equivalent to mass, because the unit kilogram stands for mass, and 5 meter, which is the unit of meter, stands for height. So our height here is equivalent to 5 meter. I told you a while ago that you don't need to solve for acceleration due to gravity, since the standard value for this is 9.8 Newton per kilogram. Now, R stands for required. So what are we going to solve? So we are looking for the gravitational potential energy, or simply potential energy with the symbol of PE. And we already know that the equation for potential energy is equal to mass multiplied by gravity multiplied by height. Now let us solve. So substituting the value in order for us to solve for potential energy, we have here mass, which is 50 kg, multiplied by 9.8 Newton per kilogram. That's a standard value for acceleration due to gravity, and you need to multiply it by 5 meter. Now, you already noticed that there are 2 units of mass here, such as kilogram, so you need to cancel. So if there are units that are the same, so you need to cancel it. So first thing that you need to do is to multiply 50 by 9.8. 50 times 9.8 is equivalent to 490. And the remaining unit for this is actually Newton. So here, then you're going to multiply it by 5 meter. So 490 multiplied by 5 meter is equivalent to 2,450 Newton meter or Newton that meter. So that is our answer. So for our final answer, so we have here, okay, we have here potential energy is equal to 2,450 Newton meter, or simply joules, or capital J. So this is the correct answer for our problem number 1. So I hope that you were able to get it. So let us have another set of example for this. What is the gravitational potential energy of a ceiling fan that has a mass of 7 kg and a 4 meter of height above the ground? So again, use GRESA. G stands for given. We have here 7 kg, which is also obvious that this pertains to mass. We also have here 4 meter, which pertains to the height. And the standard value for acceleration due to gravity, which is 9.8 Newton per kilogram. So if you listened a while ago, you can answer this one actually by yourself. But I'm going to still guide you with this. So required, or what is unknown, so you are looking for potential energy. So what will be the equation or the formula for getting the potential energy? Potential energy is equal to mass multiplied by gravity times height, all in a small letter. Remember that. Now for our solution, so you're just going to substitute the value of the following variables of mass, gravity, and height. So mass is what? 7. Wait, I'm going to remove this. This is not 7 actually. It does not look like 7. So I'm going to make it 7. That's it. 7 kg multiplied by acceleration due to gravity, which is 9.8 Newton per kilogram. And then you're going to multiply it by 4 meter. Okay, wait. I'm going to erase it again to make it clear for you kids. Okay. So we have here 4 meter. That's it. So again, first thing you're going to do is to multiply the mass and acceleration due to gravity. So 7 multiplied by 9.8, the answer is what? 68 point, wait, there's no point, make it whole number. So 68.6. Take a look at the unit. There are 2 units for mass, so you need to cancel this kilogram. So the remaining unit here is Newton. Then afterwards, you need to multiply it by 4 meter. Okay? So 68.6 Newton multiplied by 4 is equivalent to 274.4 Newton that meter. So for our final answer, our potential energy is actually equivalent to 274.4, let's make it 4, okay, 274.4 joules. Newton meter is also known as joules. So that's it. So I already gave you 2 problems for our potential energy. Gravitational potential energy, since we are using the standard value for acceleration due to gravity. So, let us check your understanding. Kindly solve the problem by yourself. I'm giving you only 1 minute to answer this one. You may start. Okay, so let us solve. So again, use GRESA as your guide in solving the problem. So G stands for your given. So we have here 30 kilogram and 4 meters. So 30 kilogram pertains to mass. Okay, wait, I'm going to make it proper. I don't know what's the problem for this one. It's not working well, so I'm going to repeat it again. So we have here given mass is equal to 30 kilogram, and then we have here the height, which is 4 meter, and then the standard value for acceleration due to gravity, 9.8 Newton per kilogram. Okay, let's erase this one. Okay, we have here 9.8 Newton per kilogram. Okay, for our required or unknown value, so we have here potential energy. And then for our equation, okay, so for our equation, so you can have potential energy is equal to mass times gravity times height. Wait, it looks like H. Okay, so it must be H. It looks like B a while ago. So mgh. Now for our solution, you can have potential energy equals mass, which is 30 kilogram, multiplied by acceleration due to gravity, which is 9.8, let's put a point, 9.8 Newton per kilogram. Okay, close parenthesis. And then multiplied by the height, which is 4 meter. So you need to multiply first 30 by 9.8. So 30 by 9 multiplied by 9.8, the answer is 294. Since there are 2 units of kilogram again, cancel. And the remaining unit is Newton multiplied by 4 meter. So 294 multiplied by 4, the correct answer is 1,176 Newton. Okay, I'm going to repeat it again. It looks like letter M. So Newton that meter. So our final answer here is potential energy is equal to 1,176 joules. I'm going to repeat that joules and Newton meter is just the same. So I hope that you were able to get the correct answer, 1,176 joules. So I think you were able to solve it well and calculate for the correct value of potential energy or gravitational potential energy. Very good. So that's it for today. See you again in our next discussion. Thank you, everyone. I hope that you'll learn new insights in our lesson for this day. I am Mom Princess Margaret Paz, your science teacher. Thank you, and see you on my next video. Goodbye.